So that is what we're going to work on right now. And it is going to be problem number 1 on your test next Tuesday. Problem number 1. Maximize the volume of the box. So we are going to find the maximum volume of a box created from a, oh, how big was that paper? The 8.5 by 11. Is that what those are? I can't even remember. Is that what they are? 8.5 by 11. All right. So let's talk about what we just did. We took this piece of paper that was 8.5 by 11, and we cut out corners, and everybody's corners were different. We don't know how big they were. Let's just say they're X. These little squares are X on the side. And we folded up the flaps here. Can you visualize that? That's what you just did, right? Okay. Now, I want to find the maximum volume. Well, how do I find the volume of any box? Length times width times height. Alright, so let's look at your box. The original paper was 11 long. Is your box 11 long?
No.
No, why not? Because you tore part of it off, right? How much did you tear off?
A square.
On this end you took off an X, and on this end you took off an X. So what is your length? 11 minus 2x. So we have 11 minus 2x for our length. It was 11, but you chopped off 2 x's. All right, now what about the width of your paper? What's the width? Well, it was 8.5. What's the width of your box? 8.5 minus 2x again? Now what about the height? I can't really draw height on my board here, but you made a box and you folded it up. How tall was your box? X. Isn't your box the height of these flaps right here? Which is X, isn't it? So there is the volume of the box. Now, problem number 1 on your test is not going to be probably an 8.5 by 11 piece of paper. What if it's a, 10 by 15 piece of paper? How is that going to change the equation? It's going to be 15 minus 2x and 10 minus 2x, right? It's exactly the same setup. Okay. Now, so question number 1, write the equation, or part A, write the equation, done. Part 2, very, very important, will always be, what is the domain of this function? Now, if I were walking down the hallway and I found this equation right here, and somebody said, hey, what's the domain? I would say all real numbers. Because there's no radical, there's no fraction, I would say all real numbers. But in context of the problem, it can't be all real numbers. Think about it. Could X be 100? Why not? It's too big for the piece of paper. So what you're telling me is there is an upper limit for X. Okay, so what is that upper limit? X is going to have to be less than what? To make this problem work, what will X have to be less than? 8.5? So could X be 7? I want you to look at that piece of paper.
No.
Could X be 7?
No.
No way, Jose. How wide is that paper? 8.5. You're cutting a chunk off both sides, right? Could you take 7 off each side? Not if you only have 8.5, right? So what could I take off each side?
4.25.
4.25, everything up to that. I wouldn't actually be 4.25 because then I wouldn't have anything left to make the side, right, of the box. So it has to be less than 4.25. Now, is there a lower limit on it? Could X be negative 100? Could X be negative anything?
No.
So what's your lower limit? 0. You can't be 0. You have to be bigger than 0. If you were 0, you wouldn't be ripping anything, so you wouldn't be making a box, right? So that's my domain. Now, what is the value of that? In a calculus class, you will learn how to do this without a calculator, but we're not ready for that, so we are going to graph this on our calculator. This is X min, and this is X max, when you graph this on your calculator. Understand that this picture has a lot going on. If you graph that function, there's a lot going on. We aren't interested in the whole picture. We're only interested in this little piece of it, because the rest of the picture makes no sense within this context. So get your calculators out, set your window so that you have this is X min and this is X max. Now what about the Y's? Now pay attention here. What did you let Y be? What's Y in this problem? This is Y equals. What does Y stand for? The volume. So tell me about a minimum volume. I'm looking at Y min now. What should Y min be? What's the smallest volume you can have? Can you have negative 18 as a volume? 0. So Y min is going to be 0. Now, what's Y max? Who knows? That's the question, right? So pick a number for Y max. One of two things is going to happen. When you graph this, you're going to see a nice little hill and be able to find the maximum. Or you're going to see something like this, which means what? You're not high enough. You're not big enough. When you put this equation into your calculator, you can put it in exactly as I wrote it. Make sure you have the parentheses though. Make sure you have good parentheses. And then do you remember how to find maximums?
How do you get out of like my X plus the T?
Well, you're in parametric mode, so you need to change it back to function mode. Go to mode.
Okay.
Change it back. Alright, then we get a second calc and we find the maximum. Here we go. And I got the point 1.585, comma 66.148 as my maximum. Anybody match that? Still working on it? Okay. Put in this equation. Make sure your Y max is big enough to see the top of the hill. Anybody else get that? Okay, good. Okay, so now we're ready to answer the question. That's the third part of the problem. These problems always have 3 parts. Write the equation, find the domain, then what's the answer? So let's look up here. Find the maximum volume. Every time you find the maximum, you're going to get an ordered pair, 2 numbers. which one of those numbers represents the volume? The Y value. So the answer to the question is 66.148 cubic inches. Now, what if the question had been, find the size of the corners or cutouts? Find the size of the cutouts that would maximize area, or volume, I mean, that would maximize volume. Nothing would change. Everything would be exactly the same, except if we wanted to find the size of the cutouts, then the answer would be 1.585, the X value. So you just have to read the problem carefully to decide if you're interested in the X value or if you're interested in the actual volume.
When you have time, can you I grabbed it right.
Operator error. Yep, hang on. We're going to do another one. Okay, so now, since we know for sure this is a test question, not just any test question, the first test question, let's have you practice another one. Let's find the size of the cutout that would maximize the volume of a box created from a 20 by 30 piece of cardboard. Okay? So right now, see if you can work through. I want you to write an equation. I want you to find the domain, and I want the answer. So the equation, the domain, and the answer to the question. So find those three things for me.
Please tell me why.
Right.
Okay, but I told you what X-min and X-max were.
Do you have passwords?
Yeah,
No.
I told you what Y-min was, and you just took a guess at Y-max. Did you follow directions? Patty, what are you doing with your iPad? Put it away. I need your calculator out. Alright, you should have an equation written. Volume equals what? What did you say? 30 minus 2x, 20 minus 2x, x. Don't forget that guy. Volume is length times width times height. Three of them. Length, width, height. Now, what did you say for your domain? It's different. This is going to have a totally different, well, not totally different, but it's going to have a different domain. We still have 0. We're always going to have 0 because x is never going to be able to be negative, right? But this time, what's your upper limit? 10. Your paper is only 20 across. So the most you could chop off of both sides would be 10. So you set up your X-min and your X-max. Y-min is still 0, right? Because Y is volume. You'll need a bigger window this time, probably. Anybody have a maximum point yet?
3.92 and 1056.3.
Anybody want to confirm that for me? I did not do it. Do I have a yay or nay on that? Somebody match it?
Yeah.
Okay. Now we need to answer the question. That ordered pair is not the answer to the question. Part of that ordered pair is find the size of the cutouts that would maximize the volume. So what are you going to put down in the answer blank? You're going to put down 3.92 inches. That's the dimension, or that's the size of the cutout. Okay? Now I need you to open up your book to section 1.7, which would be page 160. And you'll notice, I don't know if you've already started looking at your homework there, but page 160 is full of just random and assorted problems. There's no really rhyme or reason to any of it in terms of, you know, problems building on each other or anything. They're just random problem-solving situations. So, there are a couple I want to look at, and then I will just let you start picking them. We're going to focus on 1 to 35, because that's what your assignment is. So I'll get as many of them done with you today as I can. So I'm going to start with number 32. And that, you can start a homework page, they can be out of order, that's fine, as long as you have them all done. So number 32. This is what we fondly call in Algebra 1 a mixture problem. You remember doing those in Algebra 1 where you've got a certain percent solution and another percent solution? Then you mix them together and get this final solution. Okay? Now, there are many different strategies to use. Some people draw pictures of buckets or whatever. Some people set up a chart. I like to use, since my objective is to write an equation, I like to just start out. And this format will always solve your mixture problems. Amount times percent plus amount times percent equals amount times percent. So these are the amounts and the percentages of the two that we're mixing together. And this is the amount and the percentage of the final result, solution. Now the nice thing about this format is you will always in these problems be given the percentages. So for example, in problem 32, we're mixing a 20% and a 35%, and we're gonna end up with a 26%. You will always know those percentages. Then you will always know one of the amounts. So the amount I know is 25 liters, and it goes here with the 26%. Right? Now, one of these will always be X. I don't know. It doesn't matter. I usually let the first one be X. All right, there's X. And then you got to figure out the second one. But that isn't hard. It's not hard at all. You know that if you add these two together, you're supposed to end up with 25, right? So if that's X, what would this one have to be? 25 minus X. You are beautiful. That's exactly right. And before you get confused, because some of you are gonna not stop to think, you're gonna let yourself get confused. I have two things that have to add up to 25. If this one I know is 10, what would this one be? How'd you know that? 25 minus 10. So if this one's 8, this one has to be 17. 25 minus 8. So if this one's x, this one has to be 25 minus x. And then we can solve our equation. It's that easy. Let my calculator help me with my arithmetic. And I got 15 liters of 20% solution. And then 10 liters of 35% solution. Alright, try not to look at the picture they drew for 31, because that kind of sets it up for you, so kind of ignore that picture if you can, or cover it up. And let's run through problem 31 real quick, at least get it set up. We don't have to solve it, but let's get it set up. Mixture problems, amount times percent plus amount times percent equals amount times percent. So now I'm looking at problem 31. Gotta get it set up for you. How much 10% solution and 45% solution to get a 25% solution and 100 gallons of it? Does that look okay? So far I haven't even had to think. I've just plugged stuff in. Now I'll call this, something has to be X, so I'll just call that one X. And then what would this one be? How much of this would I have? Perfect. And then you're just going to distribute left right terms and solve like always. Easy enough? All right. Now I want to look at number 26. Anybody have an idea on that? Totally different problem. I told you these are all just random problems. Totally different. Anybody have an idea on 26? Some thoughts? For a long time. Let's just get started. You don't have to give me the whole equation right now, but what are some things that you have to keep in mind?
How many hours?
So
Total is 560.
the total, okay, so the question is how many hours we're doing this, so we could let X be the number of hours, what? Be a little more specific. What's X gonna be? The number of hours on which highway? On the local highway. So X will be the number of hours on the local. And then let's have another expression for the number of hours on the highway, the interstate highway. What would that expression be? X plus 2. Is that okay with everybody? How do I know that? It says in the problem, we're 2 more hours on the interstate than we were on the local. And then Caitlin said, this was Anna's thought here, she said, okay, we gotta do something with the hours. And Caitlin says the total distance is what? 550? 560? Alright, so think about making this trip. Aren't you really making this trip like in 2 chunks? Part of it's on the local roads and part of it's on the highway. So if we add up the distance on the local plus the distance on the highway, the interstate highway, that should give me my 560. I'm just writing down what I'm thinking, because I want to have an equation somehow. Alright, so how do I find distance on the local highway? Or let's just start with that, the local roads. How do I find distance? It's not the square root distance formula thing. How do I find distance traveling down the road? Distance equals rate times time. So, do I know the rate on the local roads? 45. So 45 times the time on the local roads, which is X. That is the distance on the local road. Distance is rate times time. Now we're going to add to that the distance on the highway, which would be what? 55 X plus 2. Remember, that's time on the interstate, which you said was X plus 2. And that has to equal 560. You can solve that. I got 4.5 hours for the local roads and 6.5 hours for the highway. So I don't know what the question asked. How many hours did they spend on the local highway? So that'd be 4.5. If the question said how many hours did the trip take, you would add those and say 11. Okay, I will pick 2 more and then it'll be up to you. Okay, so the next one I'm going to pick is number 23. Again, these are all random problems. So this one's totally different again. So what's your thought on this one? We're problem solving, so we're just kind of thinking out loud. What's our process or what's our thought? Number 23.
Well, you got a raise of 3.5%. So
Okay.
you divide that by what he has now to figure out like, the 36,632 divided by like 3.5%.
Okay, so let's examine that thought. That's an interesting thought. So 36,432, and you said divide that by 3.5%. Okay, would you do that for me? Oh boy, that's a big number, isn't it? So he didn't, if that's it, he didn't get a raise. His pay got slashed, right? So no, that's not quite right.
Yeah, multiply.
Okay, now wait a minute. If I multiplied this by 0.035, what's wrong with that? What's wrong with that logic?
Salary after the raise.
Yeah, this is his salary after the raise has already happened. I do not know what his salary was before the raise, right? So let's let X be the salary before the raise. Isn't that what I need to find out? Now, that's getting multiplied by 0.035, right? So 0.035x okay, then what? Okay, then we're right back to what Taylor, what Taylor had. Because she's gonna divide, and that's not gonna be right. What are you forgetting? You're forgetting something big. You forgot the original salary. This is just a raise, right? Isn't that gonna be added to the original salary? So you have the original salary plus 0.035 of it, and that's what adds up to this, right? These two add together and it's 1.035x equal to that. So now divide, and you should get an answer that's more reasonable. If Mr. Worland walked in here right now and said, Lisa, I'm going to give you a 3% raise,
He would be lit.
I would be skipping through the tulips. I would be so excited. But how would I calculate my salary? Would I take just 3% of what I make right now?
And then add it to your
And
original.
then add it to the original. You got to add it to the original. So I'm going to have 103% of my salary next year. Not 3% of it, I'm gonna have 103% of it, because I get to keep what I already have, and they're adding on 3 more percent. Right? Okay, so whatever that is, that would be the answer to the question. Alright, I wanna do one more, and then I'll let you pick some. I wanna do number 19. A sphere is contained in a cube tangent to all 6 faces. Find the surface area of the cube. Just reading this problem makes us feel like a genius, because it's complicated. This is number 19. A sphere is contained in a cube tangent to all 6 faces. Find the surface area of the cube as a function of the radius of the sphere. So here's my cube. And here's my sphere. So think of it like having a box and a ball fitting in the box perfectly. It's not jiggling around at all. It just goes in the box and it is snug. It's tangent. It touches everywhere. It fits in there just perfectly. Now our job is to find the surface area of the cube. Now, what does that even mean? What do we mean by surface area?
The outside area.
The area of all the sides of the cube, right? How many sides does a cube have? 6. What do we know about those 6 faces, those 6 sides? They are all the same. And if we said this is a side and this is a side, the area of one side would be s squared, so 6s squared would be the surface area. And that is absolutely 100% accurate. You're going to find that formula in every geometry book you look in, but it doesn't answer the question. Because the question said, find the surface area in terms of the radius, not in terms of the side. So now we have to figure out what it would be in terms of the radius. What do you think?
12.
What?
6
Well, the radius times 2
would equal.
would be S, right? Would you agree with that? S
Yes.
equals 2R?
Yes.
So I can come down here, and instead of S here, I can say 2R. And now my surface area, 24R squared, now my surface area is in terms of R, that means my variables are, and not in terms of S. Now, do these represent exactly the same area? Yes, they do. But in this problem, this is the one they asked for. They wanted us to do it in terms of R. Now, I know you're all just dying, you just want to get out of here, you want me to shut up, but I am doing your homework for you, so let's try to endure it, okay? So, who can find another problem on this page? I'll do any other problem, 1 to 35 on this page, I don't care, you have to do them all. So, 17 and then 35, okay, so we're going to do 17 and then 35. 17. The base of an isosceles triangle is half as long as the two equal sides. Write the area of the triangle. Okay. So let's draw a picture of the situation. There's my isosceles triangle. What's my formula for area? 1/2 base times height. Okay, so that's what I'm using. Now let's see what I know. The base is half as long as the two equal sides. The base is half as long as the two equal sides. So if I let the base be x, what would these guys be? 2x. Everybody okay with that? But if I'm finding area, this isn't really what I need. Isn't this what I need? How am I going to do that? How am I going to find h? My base is x, so I can say 1/2 x, but now I need my height. What? Well, I can't conclude this is a 30, 60, 90. It isn't actually, because they're not in the right ratios. But I can use what very famous theorem, since this is in the right triangle. Now, here's the deal. What's this? Half x. It's an isosceles triangle, so the altitude bisects the base. Right, so it's half x. So h squared plus half x squared equals 2x squared. In this right triangle right here. So what is half x squared? 1/4 x squared. What's 2x squared? 4x squared. Now I'll move my h over, or not my h, I'll get h by itself. So h squared equals 4x squared minus 1/4 x squared. Now let's put those together. What am I going to have to do to put those together? (16/4) minus 1/4 would be 15/4. Now I need h, not h squared, so I'm going to have to square root. That's going to be the square root of 15/2x. And that's my h. So my answer ends up being, I'm multiplying these together, so root 15 over 4 x squared. Multiply top times top, bottom times bottom. That's how we multiply fractions. And that is the formula for your area in this triangle.
So you have to take half of it.
What?
So you have to take half of
I
it.
did, I already built the half in.
Okay.
It's right here. That's the base, that's the height. So 1/2 base times height.
Okay.
All right, and now, okay, that was 17, now I'm ready for 35. All right, 35 refers to example 3, so I better look at that real quick so I know what I'm supposed to be doing. So here's example 3. Okay, all right, so here's the deal on this problem. Here's the deal. We have a parabolic dish with a 32-inch diameter. So here's my parabolic dish with a 32-inch diameter. Now, a little trick of the trade. It helps a lot of times if when you draw your picture, you put it on an axis. Example 3 kind of gave us that hint. If I set it right here at the origin, if this is a 30-inch diameter, then I know this x-coordinate would be 16, would you agree with me? And this one would be -16. Now it says that the dish that I just drew is 8 inches deep. It's 8 inches deep, which means my y-coordinates are 8. Would you agree with that? Now, which of your BFFs is that? That's y equals x squared. But the shape of it has been changed. I haven't moved it, haven't turned it upside down, but the shape of it's been changed, the size of it's been changed. Which means I have done what to the equation y equals x squared? What have I done to it? I've multiplied it by something, right? I have no idea what it is, but I multiplied it by something. Can I figure out what that something is? I think so. I know that, for example, y is 8 if x is 16. So I multiplied it by 1/32. So the equation of my dish is this. Now I'm going to take a cylinder and set it down in here. All right? So it just fits. What do I know about the cylinder? The radius of the cylinder is 8. So this is 8, which means these 2 points have x coordinates of 8. I have no idea what this y coordinate is, none whatsoever, but I know this y coordinate is also 8 because the dish was 8 inches deep. Now the question is, how tall is the cylinder? Well, if I could somehow figure out that coordinate, I would be good. I would know, I'd be able to figure it out. Any ideas how I can get that coordinate? You have everything you need up here on the board. Is that point right there on the parabola?
Yes.
That means that equation has to work. So what am I gonna do? I'm gonna plug in 8 and see which y coordinate. Oh, I can do that on a calculator. That'd be 2, wouldn't it? If I plug in 8 into my equation, I get 2. So this y coordinate is 2. That y coordinate is 8. So how tall is the cylinder? 6. So the answer to the question is 6 inches.
Is there gonna be something like that on the test?
You know what? All these questions are eligible.
Just
All these.
kidding.
All right, we got time for one more. Let's do one more. Pick another one. One more. As soon as we get it done, you can leave, or we can sit here and stare at each other. You got to do them all.
Oh, do the box problem or whatever.
Okay, we already did it. We know how to do that one. Let's do one we don't know how to do.
What do you think's the other hardest one that we haven't done yet? So bad. That a lot of people get wrong.
29. Where's 29? All right. 29 says computers grew from this number to this number. What is the percentage increase? All right, another problem from first year algebra. How do you find the percent increase or decrease? In this case, it's an increase. What's your general rule for finding percent increase or decrease? This is 29. No, it's, well, in a way, I guess. Oh my, it's change over original. So it's change over original. So the first thing we'll do is find the change, which in number 29, these are big numbers, but you can do it on your calculator. We have 824,000,000 minus 71,065. All right, so I got my change, and then I'm going to divide that by the original, and the original is the 71 number. And I got 15.95% increase. So anytime the question talks about what is the percent increase or decrease, you're going to figure out what the change is. Sometimes it's positive, sometimes it's negative, depending on whether you're increasing or decreasing. You're going to figure out what the change is, and then you are going to divide by the original every time. Okay? All right. You now should be able to get all your homework done.